Alright, hi. Today's reading is the Western Pacific Railroad Museum Air Brake Principle and Specific Equipment from Original Operating Department Training Manual 1974, reprinted in Western Pacific Railroad Manual Operation Depot, January 25th, 2005, revised Museum, July 23rd, 2011. Contents: Introduction, Section 1, Brakes, General Purpose Type of Operation, Train Air Brakes, Air, Compression, Cooling, Filter, Storage, Measurement, Transmission, Controls, Application, Friction, Brake Shoe, Wheels, Wheel to Rail, Simplified Brake System, Straight Air Brake, Independent Air Brake, Automatic Air Brake, Automatic brake System, Features and Details, A, Type Brake Pipe Reduction, Applications, 1, Emergency Reduction, 2, Service Reduction, B, control pipe reduction, engineer's brake valve service application. C, quick service. D, quick action. Initiating brake pipe reduction application. 1, service rate reductions. A, engineering automatic brake valve. B, caboose valve. C, brake pipe leakage. D, penalty application overspeed. Alertness devices. Emergency rate reduction, automatic brake valve, emergency brake valve, caboose valve, angle cock, train separation burst, uncoupled hose, defective control valve, dynometer, improper procedure. F, charging and recharging. G, overcharge and undercharge. Release control retainers, release ensuring accelerated release. Initiating of the release, automatic brake valve, dynamic braking, intercock, independent release. Car release valves, truck cutouts, locomotives, unintentional release causes, independent brake, section 2, specific equipment, the 2.6 brake equipment, 2.6E, automatic brake valve, cutout valve with the regulating valve, handle position release, minimum reduction, service application zone, suppression, handle off an emergency, multiple unit valve, multiple unit 2A valve, double ported cutout cocks, SA26, independent brake valve, release and functional application, 24RL brake equipment, the D24 automatic brake valve, brake pipe cutout cock, also called the double heading cock, handling position, release, running position, pressure mating position, lap position, surface position, emergency position, safety control clock, D24B feed valve, the KE2A rotary valve, freight marked FRGT, passenger marked PAS, freight lap managed FRGT LAP, passenger lap marked PASS lap. 740 independent brake valve, handle position release, full application freight emergency. 14EL brake equipment, K14 brake valve, feed valves, handle position, automatic brake valve, release, running, holding, lap, service emergency, handling position, independent brake valve, release, running, lap, slow application, quick application, alternating device, all alertness devices. The 6BL brake equipment, H6 automatic brake valve, brake cutout cock, lead, TRLG or trailing, dead. Handling position, release, running, holding, lap, service emergency, F4B, feed valve, LA6P, independent brake valve, alertness control, brake pipe flow indicator, delete, diesel operation, notice 10-6, switch engine, alerter, and operation. Alright, introduction. It is the purpose of the manual to provide a locomotive engineer with the knowledge of the air brake equipment so they can operate the locomotive in the train in a safe and efficient manner. Section 1 covers the principle of all air brake equipment. Section 2 is devoted to the operation-specific type of the brake equipment found on Western Pacific locomotives. Information certain herein will be an invaluable tool in attaining understanding the air brake operation. Note, while some of the equipment is mentioned in this manual, such as the alerter, is not used at the time that the Western Pacific Railroad Museum has provided its original content in this manual. Alright, brakes general purpose. Although they may seem that the first brake can only have one purpose, the railroad brakes actually serve 3 different purposes: stopping, slowing, retarding, and holding. While the distinct is elementary, it is important to keep in mind that it's study type of the brakes because certain brakes function better than some of these purposes. No single type of the brake can serve all purposes under all conditions. 2. Type of operation. There are 3 types of air brakes used on railroads. Air brake. Air brakes are served with multiple purposes so they can stop, retard, or holding locomotives or cars. The limitation in the use for the holding the purpose they will be covered later in this manual. Dynamic brakes are for electrically brake on the road locomotive. The brake convert energy to the moving train into electrical energy, dissipate the energy through the fan-cooled grids. Dynamic grids are dynamic brakes effect as are retarding brakes only. Hand brakes. Hand brakes are used primarily to hold the locomotive in the car after they have stopped. Although the overall air brake system as a train is complex, it nevertheless can be reduced with the two elements, air and friction. Since the production of flow air is so vital element of the train part, braking is necessary to understand some of the properties of the air itself. Simply stated, the air will exert equal pressure in all directions. When air is compressed, it is heated. When air expands, it is cooled. When air is heated, the pressure increases. When the air is cooled, the pressure decreases. The air contains moisture in the form of the water vapor. The warmer air, the more water will hold. When air is cold, some of the water vapor is condensed into water. Air is used in the train brake and is compressed and transmitted through the train wheel. We'll next discuss how the air will produce utilized. The following components are necessary to provide the air when braking controlling the train. The compression is an air compressor, cooling filter, filters and separators, storage reversers, storage reservoirs, measurement air gauge, transmission piping and hosing, control operating valves, application cylinder levels, and rods and shoes. Our compression. On the most diesel electric locomotives, they are compressed with a two-stage reciprocating air compressor directly off the crankshaft of the diesel engine. The compressor is running at all the time. Engine is running with the compressors. Our pumps are only demanded with the compressor or the governor. The controls are set for the start of the compressor pumping. The main reserve pressure drops into 130 pounds. It stops the pumping to unload with the compressor. When the pressure reaches 140 pounds, the compressor control switch system of the modern locomotive is an electro-pneumatic system, which pressure switches magnetic valves in addition with the actual unloaders. This is done with the compressor multiple unit locomotive consistent with a synchronized equalized piping. In two-stage compression, the air is first drawn through the intake filter into the low-pressure cylinders where the compressed air is approximately 40 pounds of pressure for the air passed through the intercooler with the high-pressure cylinder with the final compression. As we have noted, the basic facts of the air cooling during the compression is important since the air is heated by compression. If we were to allow the cooling to take place in the system later in the system, we would have compressed at a high pressure. As the pressure would drop, the air cooled. Air compressors are two types. Figure 3.1, as far as cooling is concerned, air-cooled, water-cooled, and later model of locomotives have water-cooled compressors wherein engine cooling water is circulated through the compressor and intercooler for more inefficient cooling and consequently more efficient compression. Figure 3.1 shows a three-cylinder, two-stage air-cooled, two-stage air-cooled air compressor. Water-cooled shows a three-cylinder, two-stage water-cooled figure 3.1. Since the air compressor is the source of stopping the energy with the air, obviously a single unit locomotive can be operated safely with an operative compressor. The multiple unit locomotive may be operated with an operative of the compressor since the air of the unit is fed with the effective unit through the main reserve equalizing line. In all cases, the engine man must assure himself of the proper compression, operating frequent observation of the main reserve pressure. The pressure will normally be between 130 and 140 pounds. Maybe drop slightly lower than dead heavy usage air charging the training brakes using auxiliary air devices. In case of the main reserve pressure must also always be at least 15 pounds greater than the brake pipe pressure. Alright, cooling and air filtering. After leaving the final stage of the compressor, still is much hotter than the ambient temperature outside. Since the most it has been compressed to 1/10 of the original volume, it contains a great deal of the moisture. A certain amount of the oil picked up from the compressor. Cooling filter systems serve to remove this oil from water and oil from foreign particles, which could damage the air brake controls and equipment. The air leaving compressor enters the cooling coil with then the number 1 main reserve of the figure 3.2 with the air is cooled with some of the water vapor it holds with the condensing cooling effect with the cool reservoir itself will remove about the 85% of the excessive moisture of the air and will collect the main reserve, whereas can be removed with the drain valve from number 1 main reserve. The air crosses over to the number 2 main reserve, the further cooling, and then to a central figure separated filter and with the air drain. Our figure 3.2 shows from the top side of the locomotive, the condenser unloaded, the main reserve equalizer pipe, the compressor shutter, magnet valve, the main reserve equalizing check valve, safety valve, drain valve, 2/4C brake valve, emergency valve, air horn, sanding component cutout valve, and brake off engine cock, main reserve equalizer pipe, brake pipe vent valve, brake pipe, main reservoir filter, auxiliary reserve reservoir cutout valve, main reserve cutout valve, drain valve, check valve, compressor shutout, air supply cutout valve, and air compressor. The drain valves are automatic modern locomotive. The figure 3.4 shows the on older locomotives will have only the main drain cocks. The cocks should be open and condensation drained at least as often as start of each shift of the trip. In the drain, the reservoir of the cock of the crack opens slightly, and the opening is fully quick and can cause the air to cool so rapidly the condensation will freeze, plugging in the opening. Figure 3-4 shows is your drain valve. R3 storage. Storage of compressed air and the reserve that each of the locomotive each of the car. The main storage is on the locomotive, but the main reserve each of the locomotive may usually have two main reserves. Air is stored in these reserves at between 130 and 140 pounds of the pressure is used for the locomotive. The train brake system and also the train operate auxiliary such as horn, bell, window wipers, shutter controls, etc. to protect the reservoir from overpressure. Such could occur with a malfunction with the compressor control safety valve and incorporated with the piping adjacent with the main reserve. Figure 3-5, the safety valves are set for the relief of the pressure of 150 pounds. Figure 3-5 shows the safety valve on locomotive other than reserve equalizing auxiliary emergency displacement time reserve must be but these used for the control purpose of their function is best studied with the controls on locomotives. The air that goes to the brake cylinder applying with the brakes is furnished with the main reserve supply. Alright, storage of the air freight car in the two compartments. The reserve of one section is called the auxiliary reserve and the other emergency reserve. The reserves are flat in charge with the brake pipe. When they are fully recharged for the store, the 90 pound of pressure, the air is used for the operate of the brake cars. Obviously, the supply of the braking car is limited to the size of the reserve, and the engine man must have a sufficient knowledge of how these brakes operate in order to prevent depletion and wasting of the air while the train is in motion. 4. Measurement. In the engineer, most certain concern for the measurement of the pressure compressed air, the technical name even for the measurement of the pressure, pounds per square inch, or PSIG. Pounds per square inch gauge of the pounds PSIG. However, the commonly used name, the unit measure is pounds, abbreviated with the LBS or the pound system used for the word with the pounds, and generally except for the railroads which will use this manual. However, they will keep it in mind when used with the weight. A strictly unit with the measurement is not indicated with the volume of the weight. There are 4 basic air pressure measurements the engineer must know at all times operating with the locomotive. They are main reserve, equalizing reserve on 1 gauge, and the brake pipe and the brake cylinder on 1 gauge. The pressure will indicate with the double printer with the gauge of the tube reservoir pressure is on 1 gauge and the 2 pressures contained with the word brake on the other gauge. The hands of the color coded with the code printed within the face of the gauge indicated with the pressure existing on the locomotive only. Another type of the gauge is used with the road locomotives called the brake pipe flow indicator. The gauge indicates the rate of flow of the air, but the brake pipe is actually different pressure or gauge within the measure of the pressure of the drop across the orifice. The details of the use of the indicator will be covered later. 5. Transmission. For transmission of the compressed air, with the variety of the size and the type of the piping and the hose of the one pipe of all locomotive units of the car inhabiting the most common the brake pipe that is the 1 1/4 inch pipe running through the length of each of the unit of the car with an angle cock hose and quick coupling glad hand on each of the end. With the cars on units on the couple of these hoses must be coupled. The end of the angle cocks opening a continuous braking pipe running through the length of the train. The continuous braking pipe, sometimes called the train line, but since all the rules, laws, and gauges marking the refer to the brake pipe, that is in the term that should be used. It should be noted that the brake pipe is duty whether air flows, but is nonetheless the vital element of the controlling train's air brakes is a variation of pressure of the pipe which causes the train brakes to apply or release. While the continuous brake pipe with the many pipes and the hose with the design maintained to keep the leakage at a minimum, it should be recognized that at the outset of always kept in mind that a certain amount of leakage will be present in every train. The leakage is excessive and it causes an erratic and unsafe the operation of the brakes. For this reason, limit the place of the rate leakage is the company rule in federal law. The limit is 5 pounds per minute. Leakage causes the difference of the brake pipe pressure of the locomotive at the rear of the train. The difference between the pressure at the 2 points is called the gradient, and the maximum per minute gradient is 15 pounds. In order to consistent with the safe operation of the railroad, establish the standard brake pipe pressure. The standard brake pipe pressure for freight service in Western Pacific is 90 pounds. The pressure is governed with the setting of the feed valve of the locomotive. In addition with the brake pipe, there are other air pipes of the locomotive within the engine. With the familiar with this, these pipes are used with the control locomotive brake with locomotive units with a couple of multiple forming the locomotive consists. The pipes are running with the length of the unit with the cutout cock and the hose with a glad hand on each end. The pipes are smaller with the brake pipe and or are usually identified with the badge placed for the hose connections at the ends of the unit. In order to properly unit with the consist of these pipes must be connected with the hose of the cutout with the cocks open between the units. The main reserve equalizing usually 1-inch pipe with the reserve of the name of the indicates the equalizing main reserve pressure between the units. This is done by the adding synchronizing compressor also to furnish for the air with a unit with an inoperative compressor. Another small pipe serves as a reference area with the air pressure pipe control with the brake cylinder pressure for the trailing units corresponding with the brake pipe cylinder pressure and leading unit of the pipe is used with the independent brake control with the brake control locomotive units and only the reference pipe then identified with the two different names with the being called the brake cylinder equalizing pipe with the number 22.6 equipment independent application relief of the pipe with the older number 2.4 equipment and although the pipes look identified with different locomotive they should be coupled together between the units consisting having mixed brake equipment. Also running through between the units with another small identified actuating pipe. This pipe is used to transmit the air from the leading unit. The independent control of the release the all locomotive unit brakes with releasing the train brakes in order with the independent release of the automatic application. Some of the locomotive units are also the sand control pipes that serve the control standards of the trailer and units from the lead unit. They are usually designated standard for the standard reverse, sand forward and sand reverse for the controlling the forward and reverse sanders. Most locomotives have duplicated connections on each of the main reserve equalizing actuating reference pipe. They are only necessary to hook up the one set of the hoses for these pipes, but the sander of both of the hoses on both sides of the unit should be hooked up. Alright, 6. Controls. Control of the compressor is the most complex portion of the air brake system. The controls consist of a manually operated, air-operated, electrically operated valve. The device, which will be studied detailed later in this manual. The simplest of the course is just a manual operated shut-off valve of the cock with either fully or open closed. Full open or closed. They fall in two general categories, angle cocks and cutout cocks. Angle cocks figure 3-6 are used at each end of the brake pipe. Every locomotive unit of the car angle cocks only open when the handle is in the line with the running of the pipe and closed when the handle is perpendicular with the run of the pipe. In order to operate the train brakes, the angle cocks in the train must be open except the one over the front of the lead locomotive of the unit and the one over the rear and one over the rear at the caboose of their last car. Figure 3-6 shows the figure of the angle cock. Cutout cocks figure 3-7 are used for the isolate and cutout cock and cut out and cut in certain portions of the piping device. They are usually in the end of the multiple unit pipe, the locomotive other than brake pipe, and the cutout cocks are open when the handle is perpendicular to the run of the pipe and closed when the handle is in line with the pipe. Alright, standard figure 3-7 shows the standard cutout cock perpendicular and running with the pipe, locking and standard. Both types of the cocks are grooved, both boss of the on the handle with the top of the plug with the direction of the groove indicated with the direction of the airflow. 7. Application. Application of compressor accomplished with the brake cylinder exciting with the brake rigging with the applied to the brake shoe with the wheels. Since the air will exert air equal pressure in all directions, the airflow is to brake. The cylinder pressure builds up the wheel force with only the movable portion out of the piston. The force equal to the area of the piston multiplied with the pounds of pressure psi on the motion of the car. The locomotive into the force is exerted on the series of levers, further increasing the forcing and applying with the brake shoe to the wheel. Figure 3-8 shows the typical arrangement of the brake rigging of the freight car and the arrangement shown in the body mounted with the brake cylinder. You have the auxiliary lever, the brake cylinder, the slack adjuster, the condition lever, the brake, lead lever, the hand brake connection, brake beam, brake shoes, bottom or strut, bottom mounted strut, dead lever guide, top of the rod, live lever, and dead lever, a cylinder level, dead lever guide, top of the rod, truck lever, live lever, bottom of the rod, strut, brake beam, brake shoe, hand brake connection, slack adjuster, brake cylinder, and auxiliary lever. Figure 3-9 shows the typical arrangement of the brake rigging of the diesel locomotive. Diesel locomotives have a truck mounted with the brake cylinders. Typical brake rigging, the switcher locomotive, the brake head lever, brake cylinder, hanger, strap, and brake shoe and adjuster. No, both these illustrations show the slack adjuster since the brake of the rigging is determined the measuring of the distance position of the brake cylinder travel the release position and applied with the portion a certain amount of the slack is necessary to ensure that the brake shoes are clear of the wheel when the brakes are released. The brake shoe where the slack is increased, the louder the increase is too much will affect the effectiveness of the brake. Mounted single capacity brakes that are shown with the figure 3-8 with the piston travel the initial term must be between 7 and 9 inches to ensure effective brakes of the trip. The release of the piston travel limits because of the obvious release of the piston travel increase the volume of the air needed to fill the brake cylinder build up the pressure increases into the airflow apply on the car so limited the piston travel increases too much it will be not possible to build effective brake cylinder pressure if the piston travel to increase of 12 inches on the type of the brakes are considered ineffective. On truck mounted with the locomotive the maximum piston travel must not exceed 6 inches since Distance on the locomotive, the brake cylinder pressure is furnished with the main reserve, which have adequate supply. Excessive piston travel will not reduce the actual brake forcing, but will cause the brake to apply and release more slowly. Levers are braking ring multiplied by the force of the brake cylinder. Mechanically, the degree of the mechanical multiplication is called the lever ratio. The force applied with the brake shoe can be obtained by multiplying the force of the cylinder at the lever ratio. Until the output with the force of the brake ring is the brake head with the hold of the placeable brake shoe means with the key. The brake shoes are two general types of cast iron composition, which have different characteristics, not interchangeable without modification of the braking system. See friction following. The brake ring on the car of the locomotive is designed to give it a certain brake ratio with its relation to the force of the brake shoes against the wheel of the weight of the car of the locomotive. Normally, the ratio is given for the brake cylinder pressure at 50 pounds. Since the weight of the locomotive unit not varying, the brake of the ratio stays fairly constant with the specific unit. Depending on the design, the brake ring is usually somewhere between 60 and 80%. Freight cars, however, are another matter. The difference of the weight of the load of the car, the empty car considerable, the brake of the ratio vary, but the most freight cars have known as the single capacity brake, so that the same amount of the braking force is used whether the car is empty or loaded. Brake ratios of the freight of the car can be very little as 18% for a load of the car and 75% for an empty car. Consequently, the same brake application will cause the empty car to decelerate with a quicker rate within the loaded car, or the put to any other way load car behind the empty car will tend to overtake the empty car bunch of the slack, whereas applied with the car between the load of the car will try to pull back on the load of the car, stretching the slack. The word slack is also used in here, should not be confused with slack adjusted used previously in the section regarding slack and the brake rigging. Slack in this train is made necessary for the free play of the couplers, draft gear, and the cushion movement within the draft gear, other cushion device. In other words, slack in the train movement of the car relationship to the adjacent cars. Alright, friction is the other basic element of the train brake. Friction can be defined as the resistance of the motion of the surface along another. 2 points of friction concerned with the train braking: the friction of the brake shoe against the wheel and the friction of the wheel against the rail. Brake shoe to wheel. First consideration: friction of the brake shoe against the wheel of the brake shoe. If the force with against the wheel, only certain percentage of the force becomes frictional, and force with the retard with the turning of the wheel. The percentage varies greatly with the speed. The following two will show the approximate percentage of the various speed. 80 miles an hour, 7% cast iron, 26% composition shoes. 60 mile an hour, 8% cast iron shoes, 27% composition shoes. 40 miles an hour, 10% cast iron, 28% composition. 20 miles an hour, 15% cast iron, 32% composition. 10 miles an hour, 20% cast iron shoes, 36% composition shoes. 0 miles an hour, just before it stopped, 34 miles an hour, 34%, 42%. From these figures, it can be seen that even the brake shoe force, which the engineer reads with the brake cylinder pressure, remains with the constant frictional force of the actual braking force, increasing greatly, and speeds increase the rate of the increase, the greater within the cast iron shoe with the composition shoes. The friction of the brake shoe against the wheel with this form of the sliding friction and inevitable product of the type of the friction is heat. With the heat must be dissipated through the shoe and the wheel with the air radiation. If the heavy braking continued along with the heat created faster than the radiated, resulting in the overheat of the damaged wheels. Alright, wheel to rail. The other function of the parts involve the braking and the friction between the wheel and the rail, commonly called adhesion. Adhesion is dependent upon the weight of the car. Locomotive usually expressed in the percentage of the weight is also the greater depending on the rail conditions, being practically unpredictable for wet and oily, frosty rail. In order to control the adhesion and make it more predictable, sand is applied to the rail. Locomotive standards called commonly used in percentage of the adhesion. The low speed of 25% adhesion tends to decrease the slight as speed increase the percentage of 20% over 20 miles an hour can be used. If braking force is applied to the wheel, the greater than the adhesion of the wheel sliding in addition with the damaged wheels, reducing the effectiveness of the braking. The basic principle of friction and adhesion can be illustrated with the following example. The electric motor diesel switcher 9 switcher, SW9 switcher, and the WP601 class weights of the 250,000 pounds with brake cylinder pressure of 50 pounds of the brake ratio locomotive with 82% of the brake ratio relation to the total force of the brake shoe of the wheel weight of the car on the locomotive. The locomotive has the cast iron brake shoes. From the chart of the friction percentages, we'll see that the very slow speed of 34 miles an hour of the brake force becomes frictional retarding forces. Total retarding forces is 250,000 pounds times 0.82 times 0.34, 69,700 pounds. Adhesion under average conditions, 250,000 times 1,000 pounds times 0.25 is 62,500 pounds. Thus we see the friction retarding of the force is greater than the adhesion. The result of the sliding wheels obviously for the brake cylinder pressure of 50 pounds should not be used for the locomotive at the low speed. Company rule established the limit of the brake cylinder pressure for the independent application limits being 35 to 40 pounds. Maximum pressure is governed by the setting of the independent reducing valve. The limitation of the brake cylinder pressure, reducing the possibility of sliding of the wheels, not eliminate. It also necessary to the engine man to exercise judgment, decreasing cylinder pressure over the nearest complete stop or by applying standards to improve adhesion. The observation about increased braking forces at the low speed is also applied to the train brakes. Heavy brake application at low speed, aggregated slack action, trains with the possibility of result of lading damage, train separation, and personal injury. Alright, simplified braking systems. A, straight air brake, figure 4.1 and 4.2. The simplest air of the air brakes and the disadvantage of the system used when the train brakes are obvious. All of the air application is supplied with a single source of locomotive main reserve. The train separation occurred with the car behind with the separation would lose all the braking immediately. Since all the air has traveled to the front of the train, but the cars in the front of the train would have the brakes applied with the fully before the cars with the rear of the hand had any brakes at all, it would cause a severe run in or slack in the train. The brake system becomes impractical. The train length reach of 20-25 cars. However, the adaptation of the straight air brake is used. Diesel locomotive where it is known as the independent brake, known as the independent brake. Figure 5.1 shows the straight air brake test. The main reserve of the reducing valve, the straight brake valve, the brake cylinder on the locomotive side, and then going to the car, it's brake cylinder. The straight air brake released on main reserve reducing valve, straight air brake valve, the exhaust atmosphere, and brake cylinder going into the car brake cylinder. Independent brake valve, figure 4344. Simplified version, independent brake valve, multiple unit diesel locomotives consistent, figure 43. Applied with the position, figure 44. Release position. Note the disadvantage having all the furniture for the leading with the locomotive to overcome the use for the operated relay valve such that each of the unit with the actual application from its main reserve. The reference pipe between the units necessary for this brake. The separation pipe would cause loss of the independent brake with the units, but behind it, the separation between the units rarely occurs. If the dip the units behind the separation would still have braking ability to the automatic brake portion of the locomotive the unit brake system. Alright, independent straight air brake. The applied main reserve main reserve flows into the independent brake valve through the relay valve while the brake cylinder is pressurized and going into the main reserve and the lead unit, and then going from the independent brake valve or relay valve into the reference pipe of the relay valve to either all wells of the main reserve of the brake cylinder. Independent straight valve. Straight air brake brake cylinder into the exhaust of the relay valve, the independent brake valve, the main wheel cylinder, and the exhaust going from the reference pipe from the main reserve exhaust pipe and the brake cylinder on the trailing unit. See, automatic air brake. Each of the locomotive unit car is equipped with an automatic brake equipment. The train brake system, the application for the brakes occurred with the pressure in the brake pipe. To reduce the brake is not truly automatic. It is required knowledgeable, skillful manipulation by the engineer. The only time that is really automatic is when the accidental separation of the train and the brake pipe occurs. The application of the brakes will then come and due to the full fail-safe characteristics of the system, the heart of the system control valve, which performs three basic functions: apply brakes, release brake, charge auxiliary reserve. On brake cars with the control valve known as the AB valve on the improved version of the ABD valve, the locomotive with the number 24 equipment on the D24 control valve is used. Locomotives with the 26 number 26 equipment and the 26F control valve is used. The older locomotive, the distributing valve serves the same purpose. Alright, in figure 4.6, will not be accelerate the resistor that used with the apply of the brakes for the car. Locomotive is emitted with the control valve of the pilots relieving the valve emitting the air main reserve supply to the brake cylinder, and same relay valve used utilized for the independent brakes shown 4.3 and 4.4. Alright, 4.5 shows the main reserve, the exhaust brake cylinder going to the exhaust the relay valve, which is online the main reserve, the P valve, the automatic brake valve, the brake pipe, into auxiliary reserve, where the control valve exhausts. The brake pipe goes to the next brake pipe of the car, through the control valve, the auxiliary reserve, and the exhaust, and the brake cylinder is running through the control valve. Alright, your applied automatic air brake simplified. The brake cylinder relay valve, the control valve, the auxiliary reserve, the main reserve, the automatic brake valve, the exhaust, the brake pipe, to the car, the brake pipe car, the control valve, auxiliary reserve, and the brake cylinder. Automatic brake system features and details. Applications A. The type of the brake reductions application. The brake application for the unit of the automatic brake car covers the reduction of the pressure of the brake pipe. The two general types of the brake pipe reductions Emergency reduction. Emergency reduction is extremely rapid reduction of the brake pipe pressure to zero. The rate of the reduction can be controlled once for the application initiated. Surface reduction. Surface reduction takes place at a slower rate and is controlled by the locomotive engineer. Minimum surface reduction is 6 to 8 pounds within 90 pounds with the brake pipe pressure. Maximum efficient. Effective surface reduction of 26 pounds with the 26 pound reduction is caught up with the full surface to full surface reduction. The pressure will equalize between the auxiliary and brake cylinders. With 90 pounds with the brake pipe, with the pressure will equalize at 64 pounds, giving the approximate 64 pound brake pipe pressure. Since the pressure is equalized, it can be seen with the further surface reduced, and it cannot bring any more of the braking effort. The only way the increasing the braking effort beyond the full surface is to go into emergency application. Emergency application with the pressure with the equalizing the between the brake cylinder with the auxiliary and the emergency reserve, giving the higher brake cylinder pressure approximately 70 pounds within 90 pounds with the brake pipe pressure. B. The control pipe control of the brake pipe reduction by the engineer brake valve with the surface application. In diagram 4.6, the sum of the exhausting directly with the atmosphere through the engineer brake valve. The reality of the occurs only during the emergency application. Reduction of the brake pipe pressure for the surface application must be more accurately controlled. The measure of this can be shown in Figure 5.1. Alright, Figure 5.1 shows your service control of the brake pipe reduction from the engineer's brake valve. This shows the rotary, the gauge, the equalizing reservoir going into the exhaust atmosphere of the rotary valve going from the chamber into the piston exhaust into the atmosphere into the brake pipe. Alright, the engineer using automatic brake valve handling position rotary valve with the surface position connects with the chamber. The equalizing reserve to the exhaust atmosphere. The equalizing piston arrives at the venting with the pipe, and the pipe of the air to the atmosphere. The venting of the pipe air with the continuing until the all equalizing reserve pressure brake pipe pressure equalize with the exact method of stopping exhaust equalizing reserve area for the type of the equipment will be covered later with the principle of the controlling braking the pipe reduction, making equalizing reserve reductions applying to the air brake of the valve. The engineer reducing the equalizing reserve pressure the desired amount of the type, then equipment of reducing the brake pipe pressure like amount. The quick service. Quick service. In the earliest automatic brake valve, Figure 4.6, with the reduction of the brake pipe, the pressure was made with the engineer brake valve only caused for the brakes to apply with the car to the head ends of the train before they apply with the car to the rear end. Serving the slack action, severe slack action result of the operation to overcome the effective feature known as the quick service incorporated with the control valve, Figure 5.2. And each of the control valve assists with reducing pressure, thereby speeding the action of the brakes through the train. As each of them control the train valve triggers one behind the train. Figure 5.2 shows the full auxiliary reserve going through the control valve to the brake cylinder and the brake pipe pressure splitting from the control valve, which came from the from the control valve to the brake pipe, and with from the brake pipe pressure to the control valve. Quick service is volume and exhaust out to the exhaust. Alright, D, quick action. Quick action is a similar principle of quick service, except that it occurs during the emergency application, takes air from the brake pipe at a much faster rate. As cars and locomotives become longer and brake pipe volumes increase, it is found that the quick action feature for the control valve would not propagate or trigger an emergency application forward brake out throughout the train under all conditions to overcome the vent valve that has applied with the locomotive long car. The vent valves over the brake pipe to the atmosphere when these sense rapid reduction of the brake pipe pressure for the ensuring the emergency action transmitted rapidly through the ratio for the train. Once the brake pipe reduction has been made, emergency ratio of the control valves will be to emergency application position. Stay within at least 1 minute. Nothing in a minute then can use the forced off to suppress the action should not be attempted to do so. The train should be allowed to come to the stop before recovery and release is initiated. Yeah, initiating the brake pipe reductions application. The brake pipe reductions discussed so far were those made by the engineer automatic brake valve with the locomotive. With the brake pipe reductions application can be made with the location by the other means. Surface rate reductions, engineer automatic brake valve with the manual is surface reduction are made with the brake pipe valve that has been covered in general way. The exact method serves to vary the type of the brake equipment experienced later in the section of dealing with the specific equipment. The caboose valve and the valve connected with the brake pipe caboose is the purpose of applying the brakes to the rear of the train. Figure 5.3, varying the degree of the surface reduction can be made on applying the emergency reduction can also be made with this valve. Alright, here's your end of the train rear valve. Closed in running position, notch 2, notch 3, notch 4, notch 5, full and enter emergency and release. 3. Brake pipe leakage. Brake pipe leakage can reduce the brake pipe pressure at the surface rate with automatic train brakes to apply. This occurs with no air in the V of the brake pipe from the locomotive. The leakage will gradually reduce the brake pipe pressure until some of all the control valves assume the surface application position when apply the brakes. The control valves will react with a small difference in pressure between the brake pipe with auxiliary reserve. Usually about 1 and 1/2 pounds lower pressure in the brake pipe than auxiliary reserve will cause the brakes to apply. If the brake leakage will then limit with the set by the rule of the 5 pounds per minute of the engineer brake valve, the proper position of efficient air within the flow into the brake pipe to prevent leakage and application. If the automatic brake valve with no pressure is maintaining leakage can also increase the brake pipe reduction made by the automatic brake valve, causing the brakes to set harder when the engineer makes the brake pipe reduction. Control valves move to allow the auxiliary reserve air into the brake cylinder in proportion to the amount of the reduction. Brake cylinder pressure will usually 2 to 2.5 times the brake pipe reduction. The reduction is less than the full surface control valve will assume the position known as the surface lap. The term of the lap that is used for the connection with the air valve means that the device is in the position which prevents the air from flowing through it. If the leakage is present with the air control valve, assume that the surface lap and the brake pipe pressure may not maintain. The control valve will eventually move back to the application position, allowing more air into the brake cylinders. Alright, D, penalty application, also called the safety control application. These reduction applications brought only the automatic device to the locomotive. On the Western Pacific locomotive device, the full service application on road locomotive that can be used in split reduction, full service switch locomotive to trade full service. Split reduction is one of the two stages of the small reduction, slightly delayed with all out is slightly adjusted in the fast rate of the full service. The penalty applications are sometimes confused with the service emergency application because of the both actually power knockout and devices of the locomotive to kill the power and to return the engine's idle. Penalty applications can be forestalled with suppressed, and this causing the penalty has been corrected. The emergency application cannot be forestalled. 1. Overspeeding. The penalty application occurs with the track speed, but the locomotive exceeds the setting of the device that actuates the brakes, and these settings are fouls. GP 79, 701 to 732, 67 miles an hour. GP 20, 2001, 2010, 67 miles an hour. GP 35, 3001 to 3022, 75 miles an hour. GP 40, 3501, 3544, 75 miles an hour. U23B 2251, 2265, 75 miles an hour. UB 30, 3051, 3071, 75 miles an hour. 2. Alertness device. The two types of alerting devices are used in the Western Pacific locomotive. The foot pedal, a dead man alerter, which is the electric device. The foot pedal device can also be an application pedal that does not press the alerter sound that the warning buzzer of the engineer has not touched or released the metallic object within some specified period of time. Then, if the warning is not acknowledged by the pushing of the button, the brakes will apply. The details of the operation will cover in the suppression specific equipment section. Alright, 2. Emergency application reduction. The automatic train incorporated with a separate reserve section, separate control valve with the portion for the emergency application figure 5 shown. 5.4 this is done with the emergency application available, regardless of the previous service application that may have made in order for the safety feature for the functional 2 conditions must be set. Emergency reserves must be charged. Brake pipe pressure should be at 40 pounds or more. The engine must be kept in seat. For these factors made by the making service reduction, brake pipe pressure should not be reduced below the equalizing pressure of 65 pounds with the service reduction. Any service reduction below this will only waste the air and time. Alright, figure 5.4 shows the ABD valve combined with a dirt collector with the end reservoir cutout cock into the braking cylinder release valve with the AB valve into the combined auxiliary emergency reserve and through the other lines of the brake cylinder release valve into the retaining valve, the A1 reduction relay valve, and also from the brake cylinder release valve into the automatic pneumatic slack adjuster used in the brake cylinder. With the above qualification, the emergency application is available for the following means: automatic brake valve, the brake exhaust of the brake pipe directly out of the atmosphere, rapid rate with the emergency position, although the operating position varied with the type of the brake valve. The emergency same on all brake valves, being extreme counterclockwise position. D, the emergency brake valve, sometimes called the conductor valve. Each locomotive of the cab is equipped with at least one emergency brake valve. The valve is used on cabooses. The valve figure 5.5 is connected directly with the brake pipe when the trip. The vents for the brake pipe at the emergency rate with the valve with the only two positions closed and running and open in emergency. The true emergency arises for the same reason. Oil application cannot be made with the engineer's automatic brake valve. The valve should be open and left until the train comes to a full stop. Figure 5 shows the emergency brake valve in the emergency position and closed position. Alright, your caboose valve. As mentioned previously, the caboose valve has an emergency position. angle cock. An emergency application can be caused by the opening of the angle cock quickly with the pressure low on one side of the cock of the other. For example, the charge out of the car is coupled with the uncharged cut, unless the angle cock is only slowly, and an undesired emergency application will result. Train separation bursts or uncouple the hoses. Any of the occurrence will result in the emergency application. Defective control valve of the dynamometer can cover the emergency throughout the train, shaking the emergency position, but through the quick action from each transmitted application serial to the other cards. G. Improper procedure in cutting operation air brake equipment in order to in or out, such as the changing control of the unit as to another, is a common cause of the undesired emergency. Each of the exact procedures outlined with the air brake rules and notices should be followed. Alright, charging and recharging. Charging is defined with the supplying of the air brake equipment starting with the atmospheric pressure of the equipment. This recharging refers to the replacing of the air that has been in the application. Recharging occurred at the same time release charging. Charging and recharging effect with the brake pipe friction leaks and volume of the reservoir brake equipment with the front of the train absorbing the air needed to the rear of the train. Extreme cold weather also in effect of charging and recharging. Pipe friction can cause by the fact that the air will exert equal pressure in all directions with compressed for the air through the pipe. They also express with the pressure against the inside of the pipe, causing the resistance to flow. The pipe friction reacts with the amount of the air that can be transmitted to the pipe at the given pressure. The leak of the train brake also presents to a certain extent. The extent of the leak may be also in certain limits of the previously covered under the transmission valve being charged, although the fixing and design of the equipment vary depending on whether the cars they have been completely bled off or partially bled. The problem with the front cars absorbing the air need with the rear of the train with the partial overcome the feature of the control valve known as the uniform charging. When the feature of the difference between the brake pipe pressure of the auxiliary reserve pressure is greater as it will be near the front of the train, the charge of the retarder restricting the charging port with the door of the rear of the train where the difference in the pressure of the less and the charging ports are not restricted to the charge is not retarded. It tends even out of the charging end of the train. The same effect of the recharging and recharging additional to the air supply with the brake pipe. All air will flow from the emergency reserve into the auxiliary reserve to assist the recharging. Extreme cold weather can be a factor of in charging due to the characteristic of the air. The fact that the pressure will drop the air and cool is also due to the fact that the most leak are present due to the lack of the flexibility of the gasket. When charging the air brake equipment, adequate time must be allowed for the system completely charged and stabilized on the locomotive. The compressor must be filled or is allowed to jump in the main reserve units until allowed unloads 140 pounds. At least 5 more minutes should be allowed for the rest of the locomotive equipment to charge and stabilize. A single freight car will require the 7 to 15 minutes to charge of the equipment at a time the required with the train. Charge of the train. The following can be used with the guide indicated minimum time required to complete a charge of the train, assuming all the cars with the atmospheric pressure only reserved. 25 cars for less 15 minutes, 25 to 50 cars 20 minutes, 50 to 75 cars 25 minutes, 75 to 80 cars 30 minutes, 80 to 90 cars 34 minutes. These charging times should not be arbitrarily determined. The train with the ready for the brake type. The caboose gauge reading should not be used for the purpose of the components for the air brake rules. However, the train will not charge the approximate time shown with usually indicated with the effect of such the excessive leakage present at the time. The engineer can also determine the brake pipe flow indicator with the train approaching the full charge of the brake pipe indicator specific equipment section. And I'm going to cut the tape at G.